Okay, so here is the review for test number 7. Okay, so number 1 says to solve for all values of x. So this is a rational equation. And what you want to do with rational equations is you want to eliminate the denominators. You want to get the denominators to be 1. So the first thing you're going to do is take this trinomial and this trinomial that are the same, and you're going to factor it. Okay, so these trinomials factor and become x plus 5, x minus 2, x plus 5, x minus 2. And notice that x plus 5 is the same factor as this over here. All right, so we want to get the denominators to be 1. So I'm going to multiply by the numerators by x plus 5, x plus 5, x plus 5. So what that gets rid of for all of them, right, x plus 5 and x plus 5 will reduce to 1. X plus 5 will reduce to 1. X plus 5 will reduce to 1. What's left in the denominator is the x minus 2. So that means I have to multiply all the numerators by x minus 2 also. So I'm going to multiply by x minus 2. All right, so now what we do is we reduce. So x plus 5 reduced to 1 and 1. X minus 2 reduced to 1 and 1, so I'm left with x. X minus 5 reduced to 1 and 1. X minus 2 reduced to 1 and 1. So I'm left with plus 6x minus 1. X plus 5 and x plus 5, these here reduced to 1 and 1. So I'm left with 5 times x minus 2. Okay, so now we're going to solve. So I have 7x minus 1 equals 5x minus 10. Minus 5x from both sides, add 1. So I get 2x is equal to negative 9. Divide both sides by 2, we get x is equal to negative 9 halves. All right, and then you do have to check it. Make sure that you don't get anything that's undefined when you plug negative 9 halves into the denominator. So when I check this, this does work out. All right, so let's take a look at 1b. Okay, so just like 1a, what we want to do is we want to first factor the denominators, and then I want to multiply all the numerators by something that will make my denominator equal to 1. So this denominator over here on the left factors and becomes 2x times 2x minus 1. The middle becomes 2 times 2x minus 1. And the end becomes x times 2x minus 1. All right, so let's start by getting rid of the 2x minus 1. So 2x minus 1, 2x minus 1, 2x minus 1. So what that does, this 2x minus 1 gets rid of this gets rid of this, and this gets rid of that. All right, so now I also have to get rid of the 2. So that means I'm going to multiply everything by 2. So multiplying everything by 2, this 2 gets rid of this, 2 gets rid of this, and 2 does nothing here. So I have to get rid of the x's that are left. So I'm going to multiply everything also by x. So x, x, and x. So what the x does, this x gets rid of this x, does nothing here for this one, and this x will get rid of this x. So now let's start reducing. Okay, so I have 2x minus 1, 2x minus 1 reduce. 2 and 2 reduce, x and x reduce. So I'm left with x squared plus 7x plus 12. So 2x minus 1, 2x minus 1 reduce. 2 and 2 reduce, so I'm left with this. Now watch the minus sign in there. So it's minus x times x minus 3. 2x minus 1, 2x minus 1 are gone. X and x are gone, so I'm left with 2 times 1, which is 2. All right, so I have x squared plus 7x plus 12. Distribute the x, we get negative x squared plus 3x equals 2. Combine like terms, so x squared and minus x squared is 0. 7x and 3x is 10x. Plus 12 equals 2. So minus 12 from both sides, we get negative 10. Divide by 10, we get negative 1, and then you have to check. So make sure you can plug it in your calculator to check. Okay, so I just checked -1 in my calculator and that works. All right, so let's take a look at 2. Okay, so let's take a look at number 2. So number 2 is when we will be breaking down the polynomial. So we're starting off with f of x equals x to the 4th minus 3x to the 3rd plus minus 4x squared plus 18x minus 72. Okay, so first you're going to write down all the possible rational zeros. Possible rational zeros. So remember, that is the factors of the constant divided by the factors of the leading coefficient. All right, so the leading coefficient is 1, so I really just need to get the factors of 72. So the factors of 72 are plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 8, plus minus 9, plus minus 12, plus minus 18, plus minus 24, plus minus 36, and plus minus 72. All right, so then you plug it into your calculator. Look at the calculator. Look to see where you think it crosses the x-axis, because we're looking for one of the rational zeros. So you plug it in the calculator. It looks like it crosses at -3. All right, so, and then I also want to point out it is a degree 4 polynomial, so we are going to have to break this down twice, okay, with synthetic division to get it down to a quadratic. So when we look at the graph, it looks like it crosses at -3, right? It looks like x equals -3 is a factor, is a 0. So I'm going to plug in, I'm going to do f of -3, plug it in. So -3 to the 4th minus 3 times -3 to the 3rd minus 4 times -3 plus 18 times -3 minus 72. And I forgot to put the x up here, sorry. All right, so you plug that in your calculator. Remember, we're looking for 0, right? That means I know my remainder is going to be 0 when I do synthetic division, and I'll have a factor. All right, so I plug it in the calculator all at one time, and yes, I get 0. So if x equals -3 is a 0, I know x plus 3 is a factor. All right, so now I'm going to do synthetic division to start breaking down the polynomial. So remember, what goes on the outside for synthetic division is your 0, so -3. Put your coefficients, 1, -3, -4, 18, -72. All right, bring down the 1. That's how we start. 1 times -3 is -3. -3 plus -3 is -6. Times -3 is positive 18. -4 plus 18 is 14. Times -3 is -42. Sorry, this is 18. I look like a negative. 18 minus 42 is -24. Times -3 is positive 72. These add and I get 0, and that's what I should get. All right, so now we want to look for another 0. So look at your calculator. Look to see where else it crosses the x-axis. It looks like it crosses the x-axis at 4. X equals 4. So we're going to do f of 4. All right, so you plug it into your original, right? So we have 4 to the 4th minus 3 times 4 to the 3rd minus 4 times 4 squared plus 18 times 4, that's a 4, minus 72. All right, plug that into your calculator all at one time. Do we get 0? Yes. So if x is equal to 4, that means my factor is x minus 4. All right, so again, now we're going to start breaking down the polynomial even more. Remember, put the 0 on the outside. So now I use 1, negative 6, 14, negative 24. So bring down the first number is 1, times 4 is 4. Negative 6 plus 4 is negative 2. Times 4 is negative 8. 14 minus 8 is 6. 6 times 4 is 24, and we get 0. All right, so we know this now. So I know one of my factors is x plus 3. I know my another factor is x minus 4. And now I can get this. So this is x squared minus 2x plus 6. And it equals 0, because remember, we're solving this. All right, so let's take care of this side here. So we already know the factors here and the zeros over here on the left. So x equals negative 3. And over here, x is equal to positive 4. All right, now we need to start working on taking care of the quadratic over here on the right side. All right, so I'm solving this quadratic. You can use the quadratic formula. You can use completing the square. It's not factorable. All right, so I'm going to use completing the square because my leading coefficient is a 1. Right, my leading coefficient is 1. My middle term is nice and even. So I'm going to complete the square here. All right, so remember, in order to complete the square, the first thing we do is we minus the constant over. So we get x squared minus 2x equals negative 6. All right, now I do half of negative 2 is negative 1. Square it, we get positive 1. Add that to both sides. And negative 6 plus 1 is negative 5. We factor, remember we get two of the same parentheses, so I write it with a square, so that's x minus 1 squared. All right, square root both sides. So I get x minus 1 equals plus minus. I have a negative under the square root, so it's an I. And we cannot simplify 5. So I just leave that as the square root of 5. Add 1. I get x is equal to 1 plus minus I the square root of 5. Now, it does say, so I have all my zeros. So I have 1, 0, 2, 0, 3, 4 zeros, because these are 2 zeros here. But it does say to list your linear factors. Okay, so let's go back over here. Let me write down my zeros. I have to separate this here. All right, so these are my zeros. I have x is equal to negative 3. So my linear factor is x plus 3. I have x is equal to 4. So my linear factor is x minus 4. I have x is equal to 1 plus I the square root of 5. So my linear factor minus the 1, x minus 1, minus I the square root of 5. And then we have to do the other 0, x equals 1 minus I the square root of 5. So minus the 1, add I the square root of 5. And that is your other linear factor. So these are your zeros. These are your zeros. These are your linear factors. Okay, so let's take a look at number 3. Okay, so 3A through D is we are simplifying and our expressions with exponents, and in the end we only want to have positive exponents. So we have to remember all of our rules from exponents. All right, so let's take a look at the first one. So the first one is a b to the 0 times a to the 4th b to the negative 1 times 3a to the fourth b to the negative 3. All right, so remember when you multiply same bases, so all my a's here, right, we add the exponents. I have this 3 here, so I'm just going to bring down that 3. So I have a to the first times a to the fourth is a to the fifth times a to the fourth is a to the ninth. B to the 0 times b to the negative 1 is b to the negative 1 times b to the negative 3 is b to the negative 4. So remember, to make an exponent positive, you put it into the denominator. So it's 3a to the ninth over b to the fourth. All right, let's take a look at 3b. Okay, so 3b is negative 4x to the fourth, y to the negative third, times y, x squared, times 2y, sorry, 2y, x to the negative 1 raised to the negative 2. All right, so let's start with that negative 2 there because I have that power to a power. All right, so I have here negative x to the, actually, let's take care of this and then we'll do this separately. So I have x to the negative x to the 6 and y to the negative 2. And then over here I'm going to get 2 to the negative 2, y to the negative 2, x to the positive 2. All right, so we get here, I'm going to just leave this here for a second. So I have negative x to the 8th and y to the negative 4th. And then I have that 2 to the negative 2. Okay, so let's see. This goes into the denominator. You could plug it into your calculator too, but that goes in the denominator. This will go into the denominator. So it's negative x to the 8th, 2 to the 2, y to the 4th. So it's negative x to the 8th over 4y to the 4th. Okay, so let's take a look at 3c. Okay, so 3c is parentheses x to the negative 1, y to the negative 4/3 raised to the 1/2 times x squared y to the 1/4 power. All right, so I have here power to a power. I'm going to multiply the power. So I have x to the negative 1/2, y to the negative 4/6, negative 4/6. And then I have times x squared y to the 1/4 power. Okay, so let's take care of our x's. So I have x to the negative 1/2 times x to the 2. So remember, we add the exponents when we multiply. So that's x to the 3/2 power. And y to the negative 4/6 times y to the 1/4 is y to the negative 5/12. And then this here will go into the denominator, be x to the 3/2 over y to the 5/12 power. Okay, so let's take a look at 3D. Okay, so 3D would be xy to the 1/2 raised to the 4/3 over xy squared times x to the negative 5/4 y squared. So I have here y to the 4/3 x to the 4/6 over, so I have x times x to the negative 5/4 is going to be x to the negative 1/4, y to the 4th. Okay, so we could divide the y's, divide the x's. So y to the 4/3 divided by y to the 4th. Remember, when you divide, you subtract the exponents. So I get y to the negative 8/3. And then I have x to the 4/6 divided by x to the negative 1/4 is x to the 11/12. And then this here will go into the denominator. So I have x to the 11/12 over y to the 8/3. Okay, so let's take a look at 4a. Okay, so 4a and b, so to rewrite each expression in radical form and then simplify. Okay, so remember fractional exponents. Remember, it's power over the root. All right, so let's take a look at 4a. So I have 4x squared y to the 5th raised to the 2/3 power. All right, so it's power over the root. So it's the third root of 4x squared y to the 5th raised to the 2nd power. So it's the cube root of 16x to the 4th y to the 10th. Now we have to simplify this. Okay, so make a list of your perfect cubes if you don't know them. So what perfect cube goes into 16? That would be 8 times 2. What perfect cube goes into x to the 4th? Remember, it has to be a multiple of 3, so it's x to the 3rd times x. And then I have y to the 9th times y. The cube root of 8 is 2. The cube root of x to the 3rd is x. The cube root of y to the 9th is y to the 3rd. And then I have the cube root of 2xy. All right, so let's take a look at 4b. Okay, 4b is 5xy to the 3rd raised to the negative 3/2 power. Now remember, in order to do power over the root, you have to have a positive exponent. So this is going to go into the denominator. So it's 5 over xy to the 3rd raised to the 3/2 power. So it's 5 over the square root of xy to the 3rd to the 3rd. So it's 5 over the square root of x to the 3rd, y to the 9th. All right, so now I need to simplify this. So what perfect square goes into x to the 3rd? That's x squared times x. And then x to the 8th times, y to the 8th, sorry. Y to the 8th times y. So this is 5 over the square root of x squared is x. The square root of y to the 8th is y to the 4th. And then the square root of x, y. Okay, so let's take a look at number 5. Okay, so 5 is to rewrite. And you want to use exponential notation, so you're going to put it back into power over the root. And then any place where you can simplify, you're going to simplify. All right, so let's take a look at 5a. All right, so 5a is x to the negative 2, the 5th root of x to the 3rd, y to the 4th, times y, the square root of x to the 3rd, y. All right, so the first thing I'm going to do is I'm going to take this out of the radical. So I have x to the negative 2, power is 3, root is 5. So it's x to the 3/5, power root, y to the 4/5, times y. My root is 2, square roots are 2. X to the power over the root. My power for the y is 1, and that's over 2. So now we can multiply. Remember, when we multiply same bases, you add the exponents. So I have this here and this. That becomes x to the 1/10. And then my y's become y to the 23 over 10. Okay, so let's take a look at 5b. All right, so I have the cube root of x squared y to the 4th over the 4th root of x y to the 7th. So I'm going to do power over the root. So I have x to the 2/3, y to the 4/3 over x to the 1/4, y to the 7/4. So remember, when you divide, you subtract the exponents. So I get my x's become x to the 5/12, and my y's become y to negative 5/12, and then my y goes into the denominator because it's negative exponent. So x to the negative 5/12, x to the 5/12, x to the 5/12 over y to the 5/12. Okay, and let's take a look at 6. Okay, so 6 is solving the radical equation. So remember, when you solve radical equations, you want to try to isolate the radical first, if you can. All right, and then you square both sides. If it's cube root, you cube both sides. Square root, you square both sides. So 6a is 13 equals 2 the square root of 5x plus 1 minus 7. So I'm going to add 7 to both sides. So I get 20 equals 2 the square root of 5x plus 1. I'll divide both sides by 2. I get 10 equals 5x plus 1, the square root of that. To get rid of the square root, you're going to square both sides. So I get 100 equals 5x plus 1. 99 equals 5x. X is equal to 99 fifths. All right, so you do have to check them. All right, so when I check it, I get 13 equals 2 times 5 times 99 over 5 plus 1, and then I have minus 7 on the outside. Okay, so I have 13 equals, the right side I would just plug into the calculator. All right, so I just plugged in the right side and I got 13 equals 13, so that checks. All right, let's take a look at 6b. Okay, so 6b is x equals 6 plus the square root of 20 plus minus 2x. All right, so I'm going to subtract the 6, get x minus 6 equals the square root of 20 minus 2x. Square both sides. So remember, when you square that binomial, x minus 6 squared, that's x squared minus 12x plus 36. And then I get equals 20 minus 2x. It is a quadratic, so get it to equal 0. So minus 20 and add 2x. So I get x squared minus 10x plus 16 equals 0. Now we can factor. So this factors and becomes x minus 8 times x minus 2 equals 0. I get x equals 8 and x is equal to positive 2. And now you do have to check it. So let's check. Remember, check always the original. 8 equals 6 plus the square root of 20 minus 2 times 8. So 8 equals, now just plug the right side into your calculator. Okay, so I get 8 equals 8, and that checks. Now I'm going to try 2. 2 equals 6 plus the square root of 20 minus 2 times 2. All right, so I get 2 equals, plug the right. So I get 2 equals 10, and that's not true. So make sure you cross that x equals 2 out. So my solution is only x equals 8. All right, so let's take a look at 7. Okay, so let's take a look at number 7. So I have these equations here that have these fractional exponents. So what I want to do is isolate the base and the exponent, and then to get rid of the exponent, you multiply by its reciprocal. You raise it to the reciprocal on the both sides. Okay, so let's see what we get. All right, so this is 7a. So it's 256 equals x minus 22 raised to the 4/3 power. So my base and exponent are already isolated, so I just multiply, or really raising both sides to the 3/4 power. So I get, this just becomes 1. X minus 22 equals, this side, this right side here, left side, sorry, you can plug that into your calculator. Now remember, since we're really taking the 4th root of something, right, it's 3 over 4, I'm taking the 4th root of something, you have to have plus minus. So you get 64, but it has to be plus minus 64 here. All right, so now I'm going to split it. I have 64 equals x minus 22. Negative 64 equals x minus 22. So I'm going to add 22 to both sides. I get 86. And over here, I add 22 to both sides. and I get negative 42. All right, now you have to check it. So we have 256 equals 86 minus 22 raised to the 4/3 power. So let's check it. Okay, so on the left over here we get 256. I checked in my calculator, 256, and that checks. All right, now I'm going to try 42. 256 equals negative 42 minus 22 raised to the 4/3 power. So I checked it, and 256 equals 256, and that checks. All right, let's take a look at 7b. Okay, 7b is negative 25 over 7 equals negative 4 times 2x minus 11 raised to the negative 1/2 power minus 3. All right, so the first thing we need to do is we need to isolate this. So I'm going to add 3 to both sides. So negative 25 over 7 plus 3 is negative 4/7 equals negative 4 times 2x minus 11 raised to the negative 1/2 power. Divide both sides by negative 4, and I get 1/7 equals 2x minus 11 raised to the negative 1/2 power. All right, so now to get rid of the exponent, this exponent does not have to be positive. Just raise it to the negative 2 power, both sides. So negative 1/7 raised to the negative 2 power is 49 equals 2x minus 11. Add 11, 2x equals 60. So x is equal to 30, and now you need to check it. So it is negative 25 over 7 equals negative 4 times 2 times 30 minus 11 raised to negative 1/2 power minus 3. All right, so let's check it. So I just checked it, and this works. Negative 25 over 7 equals negative 25 over 7. All right, so let's look at 8, please. Okay, so 8, we're solving the exponential equation. So what you want to do is get the same base. Once you get the same base, all you have to do is set the exponents equal to each other. Okay, so let's take a look at 8a. So that's 3 to the 3n equals 3 to the 2 minus n. So my base is already equal. They're both base 3, so that means these exponents have to be equal. 3n equals 2 minus n. Add n to both sides, I get 4n equals 2. Divide by 4, I get 1/2. Now you're going to check it. So I have 3 raised to the 3 times 1/2. Does that equal 3 raised to the 3 minus 1/2? So let's check it. Okay, so I just checked it, and they both work. You get 5, you get a decimal point, 0.19615 equals 5.19615, blah, blah, blah. Okay, so let's take a look at B. All right, so 8b is 36 raised to the x plus 1 power equals 216 raised to the 3 minus 3x. So you want them to get the same base. So another way to write 36 would be 6 squared. All right, so that's 36. We have to raise 36 to the x plus 1 power. 216 is 6 to the 3rd. And you have to take 216 and raise it to the 3 minus 3x power. So power to a power, you multiply the power. So it's 6 to the 2x plus 2 equals 6 to the 9 minus 9x. Now you take the exponents, set them equal to each other since they have the same base, and you solve it. So I get 11x is equal to 7. So then I get x is equal to 7/11. All right, so let's check it. 36 raised to the 7/11 plus 1. Does that equal 216 raised to the 3 minus 3 times 7/11? So let's check it. Okay, so this also works. I get 352.1087 blah, blah, blah equals 352.1087 blah, blah, blah. Okay, so let's take a look at 8C. All right, so 8C is 81 raised to the negative 3x plus 3 power equals 1 over 243 raised to the 2x power. So the first thing you want to do is you want to change this to just an integer, not a fraction. So it's 81 raised to the negative 3x plus 3 equals 243 raised to the negative 1 power to the 2x. All right, so that's 81 raised to negative 3x plus 3 equals 243 raised to the negative 2x. So you want to get the same base. So my base is going to be 3. 3 to the 4th is 81 to the negative 3x plus 3. 3 to the 5th is 243 raised to the negative 2x power. So it's 3 to the negative 12x plus 12 equals 3 to the negative 10x. So I have negative 12x plus 12 equals negative 10x. So add 12, I get 12x, sorry. I get 12 is equal to 2x, so x is equal to 6, and now you're going to check it. So it's 81 raised to the negative 3 times 6 plus 3 equals 1 over 243 raised to the 2 times 6 power. All right, so let's check it. Okay, so I just checked it, and they do both work out. You get the same decimal. Okay, so let's take a look at 8D. All right, so 8D is 16 raised to the 2x minus 2 times 64 equals 32 to the negative 3x. So in order to multiply these, you have to have the same base. So it's 2 to the 4th is 16 raised to the 2x minus 2. 64 is 2 to the 6. So this is 2 to the 8x minus 8 times 2 to the 6. Same basis, add the exponents. So it's 2. Remember, when you multiply same bases, you don't multiply the bases. It's not 4. The base stays the same. So it's 2 to the 8x minus 2. So now I have 32 is 2 to the 5th power here. And I have to raise that to the negative 3x power. So that would be 2 to the negative 15x power. So I'll set the exponents equal. So it's 8x minus 2 equals negative 15x. So I'm going to add 15x to both sides minus 2. So I get 23x equals 2. Divide both sides by 23 and I get x is equal to 2/3. And then you do want to check it. So plug it in, check it. And it does work. All right, so let's take a look at number 9. Okay, so number 9 is the no calculator part of it. It says for each polynomial function, find the zeros, sketch a graph of the function, and describe the end behavior, no calculator. All right, so the first thing I want to do is find the zeros. Okay, so what's nice about the first one, it is already in factored form. So I want to find the zeros is when y is 0. So I have 0 equals x squared times x plus 3 squared times x minus 4 times x plus 2. So my zeros are going to be x equals 0, x is equal to negative 3, and x equals 4, x equals negative 2. All right, so now let's talk about the multiplicity. All right, so for x is 0 and x is negative 3, right, my exponents are even, so it's an even multiplicity. So when you have an even multiplicity, the graph is tangent at the x-axis. 4 and negative 2, these exponents up here that aren't written are really 1, so that's an odd multiplicity. So when you have an odd multiplicity, the graph crosses the x-axis at those numbers. Okay, I also need to have my leading coefficient and the degree. So the degree of the polynomial is 6. My leading coefficient is, oh, remember, when the degree is even, it either goes up, up, or down, down. Right? It either goes up, up, or it'll go down, down. My leading coefficient is positive, so it means it's going to be up, up. All right, so let's graph this. So I have xy, I have 0, 4, I have -2, and I have -3. All right, so -3 and 0 are tangent, and 4 and -2 cross. Okay, so now remember, it has to be up, up. So it's going to come down and be tangent at -3. Remember, because it's up, up. Tangent, it's going to cross at -2. It's going to be tangent at 0, and then cross at 4, and then I have up, up. All right, last thing is I need my end behavior. As x goes to -infinity, f of x, your y values go to positive infinity, goes up. As x goes to positive infinity, your y values go to also positive infinity. All right, so let's take a look at 9b. Okay, so for 9b, I noticed that it's not in factored form. You have to get it in factored form. All right, so I'm starting off with 0 equals. I'm going to factor out the -x in the first parenthesis so that I have x squared minus 25. And then that's factorable again. So this is -x times x plus 5, x minus 5. The trinomial is factorable to be x minus 5, x plus 1. All right, so I have here 0 equals -x. I also have x plus 5, x plus 1, and then I have 2x minus 5, so it's x minus 5 squared. All right, so my zeros are x equals 0, x is equal to -5, x is equal to -1, and x is equal to positive 5. All right, so for these three here, my multiplicity, the exponent is 1, so that's an odd multiplicity. So that means it crosses. For the 5, my multiplicity is even because my exponent is even, so it's an even multiplicity. So it's tangent. Okay, so the degree, so remember I want the degree so I can see how the ends are going to, what's going to happen at the ends. So my degree is 5. So it's going to be up, down, or up, down this way. My leading coefficient is negative, so it's going to be this one here. Okay, so let's draw a graph. All right, so I have 0, I have -5, positive 5, and -1. All right, so we have positive 5 is the only one that's going to be tangent. That means everything over here on the left is going to be crossing. It's going to be up in the left quadrant, down in the right quadrant. So it's going to cross at -5, so it's going to come down, cross at -5, cross at 1, cross at 0, tangent at 5, and then go back down like that. All right, so now I need my end behavior. As x goes to -infinity, f of x goes to infinity. As x goes to infinity, f of x goes to -infinity. Okay, so that's it, and happy studying. Have a good night. See you tomorrow.